Hello everyone, this is Sammy. The topic is calculate maximum amount of heat, and the question is hydrogen reacts with oxygen to form water according to the reaction 2H2 plus 1O2 yields 2H2O. The delta H reaction equals negative 483.5 kilojoules. If for an experiment 4.8 grams of hydrogen are put to react with 52.9 grams of oxygen, what is the maximum amount of heat in kilojoules released? Use H equals 1.008 grams per mole and O equals 15.999 grams per mole. So let's go ahead and write down the equation that is given to us, which is this one right here. And we've got to do a few checks on it. The first check is we want to make sure that this equation is balanced. So we look at the hydrogens here on the left. We have 4, and we have 4 hydrogens on the right. So hydrogens are balanced on both sides. Also, we need to look at the oxygen. So here on the left side, we have 2 oxygens, and on the right, we have 2 oxygens. So those are balanced as well. So this is a balanced reaction, yes. Second check is max moles. What are those? So the max moles of hydrogen is 2, and the max moles of oxygen is 1. Okay, and that will come in handy when we get into the first step. So the first step is find the limiting reactant. So we have 2 reactants. We have hydrogen and oxygen, but the question is, what is the limiting reactant? So we have to start, we'll go ahead and start with the hydrogen. We're given 4.8 grams of hydrogen. So go ahead and put that down right there. We've got to convert from grams to moles. So we multiply by 1 mole hydrogen over 2.0016 grams of hydrogen. So the grams will cancel out. We're left with moles. Now we need to divide by the maximum number of moles, okay? And in our case, remember we said that the coefficient that's in front of the hydrogen is the maximum number of moles. So we're going to divide this by 2. So you can, same thing, you can say times 1 over 2 moles is the same thing as dividing, okay? So the moles will cancel out, and we're left with a unitless number, which is 1.19, okay? We do the same thing with the oxygen. We're given 52.9 grams of oxygen. So we'll start with that. We've got to convert that into moles. So multiply that by 1 mole oxygen over 31.998 grams of oxygen. So the grams will cancel out. We're left with moles. And we need to divide by the max number of moles of oxygen, which is 1 from the balanced reaction. So we just multiply by 1 over 1 mole oxygen, O2, and the moles will cancel out. We get 1.65. Which number is smaller? 1.19 or 1.65. The 1.19 is smaller. The smaller number is going to be the limiting reactant. The larger number is going to be the excess reactant. One note to mention is the reaction stops when the limiting reactant is completely used up. Okay, so the limiting reactant here is going to be the hydrogen, the H2. Step 2 is calculate the maximum amount of heat by using the formula below. Delta H reaction divided by moles of limiting reactant times 1 over the molecular weight of the limiting reactant times the given mass of the limiting reactant. Okay, so the heat of the delta H of reaction is given right here. It's negative 483.5 kilojoules. Okay, whenever we're given the delta H of reaction, we can divide that by any of the moles of the reactants or the products. So we can take this number and divide it by 2 moles of hydrogen, or divide it by 1 mole of oxygen, or divide it by 2 moles of water. But in our case, we'll need to divide it by 2 moles of hydrogen because that's the limiting reactant. Okay, so that's why we have this right here. Multiply it by 1 over the molecular weight. Well, molecular weight is usually grams per mole. So 1 over molecular weight would be moles per gram. Okay, so that the moles will cancel out, and we're left with kilojoules per gram. Okay, we need to multiply that by the given mass of the limiting reactant. That was given as 4.8 grams of hydrogen. So multiply that by 4.8 grams of hydrogen. The grams cancel out, and we get kilojoules. So the answer is negative 575.6 kilojoules after doing all the math, and that's the answer.